So we're looking at problems in chapter 9-4, hypothesis test for proportions. In this chapter, problem number 13, according to the Internet Monitoring Company, in 2012, the company stated that 71.8% of all email was considered to be spam. A system manager at a large corporation believes that the amount of email spam is at 80%. He examines a random sample of 500 emails from his company server and finds that 382 of the messages are spam. So the question is the company manager correct? So, are the conditions to meeting the z-test hypothesis met? Well, in this particular case, if we do n times p, we get 500 times 0.8, which is approximately equal to 400. It actually is 400, and that's greater than 10. And n times 1 minus p is 500 times 0.2, which is equal to 100, which is greater than 10. So the initial conditions are met, and we can assume that the 500 emails of the company is less than 20% of the company emails in total. So therefore, we can assume normality for emails. So we want to state the hypothesis. Our hypothesis, H naught, is P is equal to 0.80, or H 1, the alternative, P is not equal to 80. Okay, and now we want to compute the test statistic, and if you will recall, the several things that we need to know for the test statistic is p hat. P hat is equal to x over n. In this particular case, we had 382 emails out of 500 that were considered spam. And the other thing we want to do is calculate sigma p hat, which is the square root of p hat 1 minus p hat, or actually it's just p, I'm sorry, it's just p in this case, divided by n. Well, in this case, we're going to use p, which is 0.8 times 0.2 divided by 500, and we get approximately equal to 0.0179. Now we have to compute the test statistic. Our test statistic is z in this case, and it is p hat minus p divided by sigma p hat. So in this case, we found that p hat was 0.764 approximately. We subtract out 0.8, that's the p naught. And then we have the standard error of 0.0179. When we do this calculation, we get a negative 2.011. Well, Now we have to look at a p-value. And to find the p-value, we go back to this idea of a sampling distribution for p hat. And if you recall, p hat is normally distributed. And we're looking at since it's a two-tailed test, we're looking at 2.01 and up here at 2.01. And so we're looking at a two-tailed test. So we're looking at the values of the tail on either side. So the p-value, and when we look under the table, is going to be twice the value at the lower level at negative 2.01, which when we look in the table in our standard normal curve, we get 0 to 2. And if we double that, we get approximately 0.044. And if we did this by technology, the technology will show us about the same information. If we use the 1 prop z-test in the calculator, we'll get approximately the same answer. So from this, at the 5% level, the p-value is less than 0.05. So we reject H naught, and we state that in fact the number of emails, or the percentage of emails that end up in spam, are not equal to 80%. In our second problem, this is problem 24 in the same section, a cable company offered a random sample of 400 customers free access to a new sports channel for 1 month. The company then asked these subscribers if they would pay an extra $10 per month for continued access to a new channel. Of the 400 sample customers, only 25 of them said that they would pay extra money for continued access. The marketing manager for the company believes that more than 7% of the subscribers' base would purchase the new channel. Do you believe the marketing manager is correct? Tested alpha is equal to 0.01. So, we always question whether the assumptions are true. And we found out that n times p is equal to 28, which is greater than 10, and n times 1 minus p is equal to 372, which is greater than 10. And our assumptions that 20% or more of less than the total customers has been sampled, and of course we make the assumption that this company has considerable more customers than 400, so we do assume that we've got a sample of less than 20% of the customer base. And so we think that our assumptions for normality has been solved. And so now we ask the question, well, what is our hypothesis test? So in this particular result, we will put in our hypothesis test. So P in this case is equal to 0.07. And alternative hypothesis is P is greater than 0.07. So this is going to be a one-tail test, obviously. The things that we do know is p hat, in this case, is x divided by n. X is the number of customers that want continued access, which is 25, and out of the 400 customers that were surveyed. And when we do this calculation, we get 0.0625. Now we want to do our standard error for p hat. Right, so this is going to be p naught, 1 minus p naught divided by n. And in this case, we get the square root of 0.07, 0.93 divided by 400. And this is going to equal 0.01278. So now we want our test statistic. So our test statistic T, or Z, I'm sorry, it's a Z test here, it's a one prop Z test, is equal to p hat minus p naught divided by sigma p hat, right? And in this case, Z is equal to p hat, which is 0.0625 minus 0.07, and this is divided by 0.01278, and we get a Z value is equal to a negative 0.5877. So now we have to calculate a p-value, and again, this is a one-tailed test, so we go to our sampling distribution for p hat. Here's p hat, and here is 0. And we're looking at greater than, and so our negative 5.8 is probably about right here. Negative 0.59, we'll go up 1. And we're looking at this area here under the standard normal curve. And when we do it, we have to look at the value below -0.59, subtract the 1 from it, and when we do that, we get a p-value is equal to, I believe, hold on just a second, I'm going to do it on my calculator as well. I'm going to go over to stats, hit my calculate key, go to option 5, and my p-value is 0.07. X bar again was 25. We had 400, and now we come down, and our p-value is 0.72. So our p-value, if we did it using the table, it'd be 1 minus 0.2810, and in this case the p-value is equal to 0.7216, right? So this p-value is pretty large, right? So because the p-value is greater than 0.01, we do not reject. Right? We do not reject, and we say that based upon this sample, there is no evidence to believe that the number of subscribers that would purchase the new channel would be greater than 7%. So now in the last problem, we're going to look at a consumer report study that indicated that more than 55% of the children between the ages of 8 and 12 years old had a cell phone. A survey was conducted in 2012 to confirm this research in a survey of 802 randomly chosen students between the ages of 8 to 12 years in 5 states, and found that 449 of these students had a cell phone. Can you claim that the Consumer Report is correct based on this survey? Use alpha is equal to 0.01. Well, this time we're going to use our calculator, but we're going to set up the hypothesis test first. We already know under finding the conditions of normality that indeed in this particular case n times p is going to be greater than 10, and n1 minus p is going to be greater than 10. So that portion of the assumptions are correct. And we can also assume that 802 children chosen out of the population is also less than 20%. So we can use the normal assumptions for the sampling distribution for p hat. So now we're going to create our hypothesis. So H naught in this particular case is P is equal to 0.55, right? And H1 is, it says here in this case, we want to find out if it's greater than that. So we want it greater than 0.55, right? So these are our hypothesis tests. And we go ahead and we select the stats key. We come over to test. We hit option 5. And then we put in our data. We had P naught is 0.55. X is 449. That had a cell phone. N is 802, and we pick the alternative hypothesis. Then we hit calculate. Now we come over here, and when we hit calculate, we get the one prop z test information. We get a z value of 0.56, and a p value we get is 0.2874. So our p-value is equal to 0.287, and since the p-value is greater than 0.01, we do not reject. And we conclude that, in fact, based on this information, there is no evidence to conclude that the percentage of children between the ages of 8 to 12 years old had a cell phone greater than 55%. Well, that concludes our problems in Chapter 9-4. Please look over the problems that we have had so far in this chapter, and if you have questions, bring them up into class.